Hey, welcome back. This is John Waddick, and because there's so much good information in Chapter 9, we have to split it into parts 9A and 9B. So for today, we're going to look at just the first part of the chapter, 9A. Some of this will be review, but you'll learn some cool things that maybe you didn't realize how to do. All right, on tutorial 9A, which is going to be pages 297 to 302, you're just going to make a block diagram in front panel that looks like this. These are numerical controls. I'm sorry, when they're white, they're controls. We've got a vertical scale. That's an indicator. We've got an input scale, and then we have some output scales. Now let's take a look just from the top. I mean, you know how to place these things right now. But let's say you want someone to enter a month. Well, let's say some bonehead comes over here and says, oh, I'm going to enter month 0. Okay, I'm going to hit enter. Oh, you see what happened? What if they hit month minus 22 or 25? It makes it 12. All right. If you make too big a thing, let's say you put month 13. It comes 12. So this does not allow anybody to put anything in except the numbers 1 through 12. So how do you do that? Well, you right click, you go to properties, and you go into data entry, and you can put a minimum of 1. You want to, normally it's on default. Get the default off. Now put it back to the default. 1, maximum of 12. Now if this responds to values outside the limits, coerce means, I want to go to coerce. Coerce means if you put something outside those limits, let's say less than 1, it'll snap it to make it 1. If you put something outside 12, you can either ignore it or you can force it to be 12. And then I'm going to put an increment of 1, and I'll just put coerce to nearest. The data type, a U8 means unsigned, because we don't need a sign bit. Negative, there's never going to be a negative month, and that should be pretty good for that. Okay, output month, you're going to put a slide scale. You're going to go from 0 to 12 on that. These data types, these are just numerical controls, and all I changed on each of them is I right click, properties, just make sure you put them to the right data type. So data type, you click on data type, and you can make it either an unsigned integer 8, unsigned 12, integer 8, and integer 16. The difference between these is the integer 8 is not able to store as large a number as a U8, because the integer 8 has to use up one of its storage bits, one of those 8 bits, to keep track of the sign, plus or minus. Likewise, an I16 could only hold a number that's really 15 bits long, not 16. All right, lastly, this input on the slider here. So once again, there's a choice between a linear and a log scale. Log scales are those that have the same distance between powers of 10, whereas a linear scale has the same distance between each unit. So when you double the value, you're going to double the number of tick marks you move. All right, so linear scales are what we're usually used to. Log scales are good when data has an enormous range and it can't be displayed nicely on a linear scale. To get make a linear into a log scale, there's representation. Nope, it's not there. Okay, I can always get to it by scale down here. I'm sorry. So let me click scale, and there is a mapping and logarithmic. All right, so that's quite a hidden path there. Probably in properties, I can just go to properties quickly. Scale, there's logarithmic. It might be just as easy just to go to properties and go to scale and hit logarithmic. All right. So that's all there is. When you go and run this in continuous mode, you can decrement your months. You can figure out how big a number you can put into a U8. So just try something pretty big like 258. If it's above what it can handle, it'll just put the largest number it can. So if I tried 255 here, notice a 127 is as big as it can go. All right. You're good for the rest. Answer the questions on the sheet and you can get a stamp. Let's open tutorial 9A2. Okay, let's tile left right, see how you're going to do it. All right, so what we're going to do is you're going to have 4 arrays, an x1, y1, x2, y2, and I'll just make this a little bit bigger. And then you're going to plot. I'll make sure you have a legend, so you have different colors, and you should have something that looks like this. We can change these axis titles. This could be just y, and this is x, because they're not really time. All right, so there we go. That's looking a little bit better. Okay, on this right side, we have, or I have made a sub VI. Okay, so this is going to be something that can make a dual plot. So let me just double click on this. So you know how to make a sub VI. You would, box everything in, and then you're going to do edit, create sub VI. Okay, either sub VI from snippet or just create sub VI. All right, the way I did the sub VI is, okay, I first made this right here where I did the x1, y1, x2, y2, build the array, bundle. We've done these things before in XY graph. All right, so I highlighted this much right here, and I made the sub VI. Actually, let me go back to my original one. Tutorial block diagram. Okay, yeah, I just forgot how much I did there. So let me just go back to the dual plot. Okay, so I just highlighted the bundles and the build array, and then I did edit, create sub VI, which then created this thing. Okay, and then you're going to go in here. Remember to change what the icon looks like. You come up here on your sub VI, you double click on it, and I made something like this. What I did was I looked up under the glyphs and I found graph, so I brought this graph in, okay, which is the axis. I'm going to just hit escape, and then to get these double lines, I just used the line tool, and I just drew a line. Okay, so you do something similar. Maybe you do a different glyph, I don't know, but I'm happy with the way mine looks. Okay, so sub VIs are a nice way of just encapsulating a lot of information so that your block diagram looks a lot neater. All right, so I am going to just go back to our regular VI by closing this down, file, close, and that's all there is to it. Now you're going to want to save or make your array data. Remember, you go to data operations, make current values default, so every time you open this up and your instructor comes over and runs it, it's all ready to go. So that's what your 9A2. The only thing new is you just putting your plot inside of a sub VI. All right, good luck with that. You shouldn't have any trouble. The tutorial 9A3. Okay, and here we're going to look at how for loops work and how Labview schedules things and how it's going to execute. Okay, so I've got kind of a big block diagram, so I just reposition it so you can see the whole thing. Okay, so outside I got a while loop that's going to be controlled with a stop button, and inside I'm going to have 2 loops, and what these loops are going to do is I'm going to put a loop 2 iteration in here, and that's going to be how many times I'm going to repeat loop 2. Loop 3, that'll be how many times I do this one. But inside of both of these are the same kind of things, and I should just remind you that there's a wait up there, and that's a wait. Okay, I've got some LEDs up here. So what's going to happen is loop iteration value is going to come in, and we're going to determine whether it's even or odd. We're going to do that by using quotient remainder and dividing by 2. If you take a integer number and you divide by 2 and the remainder is 0, then you got an even number. Otherwise, we're going to knot that and we're going to indicate that it's an odd number. So what I'm going to do is first run this, and you're going to run this as well when you do it. And let's take a look what happens over here on the block diagram when both loop iteration numbers are the same. Okay, so I'm just going to move this over a little bit. Can't see my file run. All right, so I'm going to run this. Okay, notice the integers 2 and 3, they're kind of going in unison. So it looks like both of these loop 2 and loop 3 are being done simultaneously, but they're really being done one right after the other in very quick succession. But this is going to continue on until I hit stop. Got to hold stop down. Might have to hit it a couple times because it's only going to stop if see, it's still going. It's hard to stop it because I actually probably should have my stop inside one of these loops. But in any event, if you have to stop something that's running wildly, the nice thing about Labview is you got this stop sign. It'll stop things under any circumstances. Now let's take a look at the execution of this program when we make loop 2 iterations and loop 3 iterations different. So I have 3 and 6. All right. Now when the loop iterations were the same, these two seem to be executed in unison. So let's give it a start and let's watch. All right, so at first they both are doing the same thing, but once the first loop finishes, Labview allows the second loop to catch up and finish it before going back. So at least for the first 3 iterations, they go in unison. But then when loop 3 has to do its final 3 iterations, you'll see that it does its stuff by itself. Okay. So watch that and try that in your own, and you'll have a question to answer. And we're going to open up 9.4, 9A4. On 9A4, what we're going to do is we're going to embed an outer for loop inside, and then put an inner for loop inside an outer for loop. All right. So let me just make this a little bit bigger so we can see the whole block diagram. All right, so you've got an outer for loop, and I should probably have a label on there, for loop, and we got a for loop on the inside, another for loop. All right, now from previous array makers, we know that the outer loop gets executed once, and then it does the whole inner loop many times and finishes the inner loop. Okay, then it goes to the outer loop, gets a new value, and then goes the inner loop and does that. So now one of the new things is right over here, if you right click tunnel mode, there's indexing. Okay, so now what happens with indexing is that if your loop is being run multiple times here, it'll just keep stacking up values and not send them outside of the loop until this whole inner loop has completed all of its iterations. Okay. Now out here, there's another auto index. So what essentially is going to happen is we're going to fill a whole row of our array, then send it out, and then that row is going to get stacked up. We're then going to start a new row, go around the inside for loop, put another row out, and those rows are going to stack up. All right, so what you're going to see over here is, first of all, let's have an outer loop. Let's say the outer loop does, which is going to control how many rows we make. So let's say I'm going to make 4 rows. And then 1, 2, 3, 4, 5. So let's say we have 6 items on the inner loop. Okay, so let's go ahead and run this and see what happens. So as you can see, the inner loop goes through all its iterations, then the outer loop, and as soon as the inner loop is done, you'll see this inner loop output will change because these is this is the current row that just got created. And then when all of the rows are done, at the very end, you see the final output. Okay, and then I just transpose the array. So let's take a look at the block diagram one more time. And so this outer loop controls what row, and then the inner loop is going to fill all the columns in that row. Those columns, each of those filled rows are going to get stacked up, and not until you're done will this outer loop show up, and then the transpose will be done. So just a nice little program to let you see how an inner for loop and an outer for loop interact with one another. Okay, so we'll just tile left, right, and you should have some fun with that one. So let's close this one. Whoops. Okay, 9A5. Looks just like the last one, although we've made some changes. So let's see. Okay, so this time what we did was I changed the tunneling from auto-indexing to just the last value. So I do that on the inner loop. That means that the only thing that's going to get sent out of this inner loop is the last value that gets created here. Those values are going to get stacked up here in the outer loop. Since there's auto-indexing here, those are going to stack up, and then we're going to just get a single dimension array when we get out. So let me just show you what happens. So let's say we do the same thing. We want to do, let's say, let's just do three outer loops and 4 inner loops. Now remember, each loop starts with the iterator I starting at 0. Okay, so let's run this and see what happens. Okay, so it's generating new things. Now notice 3 was the last thing that got created because we're sending the output of the outer loop. So you see that the output of this thing is you're just going to get a single array being created because the inner loop, it's going to have 4 values that it produces, but it's only going to send its final value out. So you can answer the questions about the difference between auto-indexing, which stacks up all the values and sends them out after the loop is done, versus last value, which throws away everything except the very last value. So there's very few occasions when we would ever want to use last value. So auto-indexing is the thing you really want to do most of the time. Okay. Okay. So let's tile right on this one and see what's new here. Okay. All right, we're going to deal with something called shift registers. Okay, let's take a look at shift register and how you actually even create one. First thing, they're going to be used with loops of some kind. So I'm in a block diagram and I'm going to put a structure in here and I create a for loop. All right, to create a shift register, you go onto the left side and you right click on the edge and you go to something called add a shift register. It's right there. So you add that and add something on both sides. The shift register is really a feedback mechanism to get data is coming out of the right side and puts it back on the inside. Okay, so the first thing you're going to do, let me just show you here, is we have a for loop. We're going to hardwire in a 5. If you have to hardwire a value in, remember what you do. You just come over here, you right click. Oops, I'm sorry, right click, and you're going to create a constant. And I'm just going to make that a constant 5. All right, so we're going to run this thing 5 times. We're going to have an initial shift register value. Now what happens is this initial value comes in here and it's going to get added to this I. Okay, so I is going to start with 0. So first time it's going to be the value plus 0. And then that's going to come over to this shift register and nothing's going to come out of this final shift register until we're done. But what's going to happen is this result then gets sent back over to this triangle. All right, and it's just going to keep going around, taking this result and putting it back here. So just to recap, the initial shift register value comes in the first time, but then each subsequent time, what is used here on the left side is what got computed here on the right side. All right, so as we watch this, we're going to see the left and right shift registers going to work. All right, so there's just a simple add. So I'm going to tile this left, right, and let's go ahead and run this. So let's say that my initial shift register, and this is 9A6, let's start with that even at 0, okay, and see what happens. Now what we're going to want to do is we're going to run this program in single step mode because we need to see what's happening step by step through this program. Okay, so I'm going to just come to this one right here. It says start single stepping, and I'm going to go ahead and hit it. So it enters the loop, okay, and now next thing is it's going to do this addition function, and then it completes the loop. So after the first time through, you've got 0, 0, 0. Okay? Now the next time through the loop, we're going to hit this one. The I value is now 1. So we're going to add 1 to 0, and that's going to give us a right side shift register of 1. Okay. Now that right side shift register, as soon as I hit step, it's going to get shifted over to the left side shift register. You see? Now it adds 2 because the I value is now 2 and makes the right side shift register 3. Well, I think you can probably guess what's going to happen next. When I hit go, the 3 is going to get shifted over to the left side. The new I value is going to be 4. Or 3, I'm sorry, and then now we're going to get 6. We run it one more time, the 6 gets shifted, the I value goes up to 4, we now get 10. We're going to, I guess, do it one more time, and we're done with the loop. Okay? So just a thing with shift registers, if you want to keep doing an operation and sending the output back to the input, like you want to do a sum of something, it's a nice easy way to do this. I'm going to tile this left right so you can see what you need. In fact, let me just make it full screen. All right, here what we're going to do is we're going to create 2 shift registers. Okay. In fact, on the last video, I probably should have shown how to make a shift register in the first place, but let me do it here and now. So first off, let's say I'm going to put in a structure which is a for loop. All right, I put my for loop in, and you can do a shift register with other types of loops as well. But all you do is you come up here on the edge of the for loop and you right click and you put you're going to add a shift register. Okay, so it adds 1 to each side, and then you can wire stuff to this. The color is going to depend on what type of data that you put in. Now, if you want to put 2 shift registers in, okay, what you do is you go to this left side again and you right click and you're going to say add a shift register. Okay, and well, I guess I didn't want to do that. Let's edit, undo that. I'm sorry. Actually, I want to do one that cycles back into 2. And okay, so I'm going to right click here and I'm going to add an element. Okay, so we want to add an element. That's going to bring you a second one. Okay, so that's what I've done up here. Then I've just wired these 2 controls into it and then put some indicators in at various places. So we're essentially going to do the following. All right. Now what's going to happen now is these 2 shift registers here on the left. When we get this started, we're going to put 2 initial values in. And then after the loop is done once, this value from the shift register is going to go and replace the top shift register on the left. What happens to the bottom one is whatever was in the bottom one it was in the top one, it's going to get shifted to the bottom one. Okay, so essentially the bottom shift element is always going to be not the current right side shift register, but the right side shift register from an iteration ago. Now these words probably don't mean much, so let's just take a look at the execution and watch what happens here. Okay, so we're going to put some initial values in. So let's say put 3 and 6 or something. Okay. All right, I'm going to run this single step so that we can watch what happens. So we come in, we get into the loop. All right, the 3 and the 6 get shifted in. The I value is 0. We're now going to add the bottom shift register to 0. That's going to give us a right side shift register of 6. Now when I hit step again, you're going to watch where that 6 goes. That 6 goes up to the top left shift register. The 3 that was in that shift register on top now goes to the bottom. All right, we're now going to add 3 plus 1, going to give us 4. Okay, now watch what happens when I start this loop again. The right side shift register is going to go into the top left. So we're going to end up with a 4 on the top, and then the 6 is going to get shifted down. Okay, you see that? And then we're going to keep doing that. You see the 8 got shifted over. And now we have a 12. That's going to come back. And we're done. Okay? So you run that, play around with it, and see what you get. Now let's go to program 9.8. All right, so we're going to use the practice problem in section 9.33. The book says use 8.33, but we're going to do 9.33. Okay, so I'm just going to close this, and I'll open it. I'll show you what it looks like. So this is problem 9.8. All right, it's in the book, so I can just show it to you here. So I'm pretty much giving this away to you, aren't I? All right, I should put labels on here: increment, multiply, and greater than. Okay, so the idea is this is going to mimic the growth of some cells in a culture. So you start with, let's say, 1 cell, and then after it reproduces, there's going to be 2 cells. Now the shift register is then going to bring the 2 over here, double it, and it's going to be 4. And you're going to keep going around until the target cells is greater than, well, the amount that number of cells currently is greater than the target cells. You're gonna end that. All right. So there's a little wait in there. So you come in here with target cells. There's a 1 second delay. Let's just see what happens. So we run it. We have 2 cells, then 4, then 8. Okay. And each time we do this, we're going to count 1 iteration as an hour. Now you're going to see, you see how doubling things every hour? You can see that things that reproduce quickly, we can get up in 17 hours. We're over 10, actually that's 100,000 cells. So you start getting a little sore throat in the morning. By the time you wake up the next day, man, you got a wicked sore throat because all those strep cells have multiplied. All right, so this one has 2 shift registers. Remember how to get a shift register. You right click and you add a shift register. Okay? Nice, easy program for you. Close that one down. I'm going to save it. All right, now the next few, I'm going to leave a little bit more up to you. Okay, so we have 3 instructor problems, but let's make sure that you know how these are supposed to work. So we'll look at instructor 9A. I'm just going to do the front panel here. So you're going to create a for loop that can do this operation. Let's say 5 factorial, for instance. And I'm going to I want to do that in highlight execution mode, but let's just run it. It gives me 120. If I go bigger than that, let's do 8 factorial. All right, so one of the things you have to do is figure out at what point. Now I've already figured out that I can't go beyond 12. So notice how I've coerced this 12. If I try to put in something bigger than my thing can do, I want to do n factorial 58. It coerces it down to 12 and makes it run like that. Okay. So there's also a factorial function in LabView. Okay, so I will show you that quickly. You're going to find it in the mathematics function. So let's just do a new blank VI. Go over to here. So you go to mathematics, and it's going to be in elementary mathematics. Where are you? Elementary, and then from there you're into discrete. Sorry. Come on, get out of there. All right, let's try again. All right, so we're going to math, and we're going to elementary. Okay, now we have to go, it says to go to discrete, but that's not where we're going to, oh, there's discrete. Sorry, we did find it, and there's factorial right here. All right, so your factorial, so that's one thing. You put in your value of n, you're going to get out a value. But you also want to use a for loop to create your own factorials. So remember factorial, like 3 factorials, 3 times 2 times 1. And 0 factorial is defined as 1. All right. So maybe with some shift registers or for loops or whatever, you can make your own factorial. All right. Well, good luck with that. I'm not going to save that. File close. Instructor 9A2. All right, this is going to create a sequence. So let's say I want to create 12 items. Okay, let's run this. All right, so what it does is the first item is 1 and the second one is 1. And then you're going to go 2 and 3. So let's show you really what's going on here. So the first one just has to come in as a 1, and the second one has to be a 1. So the first 2 are 1s. Then the sequence can begin. The 2 is the sum of the 2 previous ones. And then this 3 is the sum of the 2 and the 1, the 2 previous ones. So if you think a little bit about shift registers and adding an element, remember, the second element on the left side will always be retaining the shift register from the right from the previous, the second to last iteration. So that's my hint. Use shift registers and maybe add a second element on the input side. But this is a real fun little thing. You get this working, I'll be real proud of you. I know you can do it. Now, last one, we're just going to open up 9A3, and this I can show you tile left and right. Okay, so you're going to create a temperature array. So you're going to have a minimum, a temp, and a maximum, and you're going to just create one column. So the first one's going to be all Fahrenheit. Then we're going to send that to another VI that converts that into Celsius. So if I say I want my minimum temperature to be, let's say, 32 degrees Celsius, and I want my increment to be, I don't know, let's say 10 degrees, and then I want my maximum to be, well, 212. Let's see what happens. So let's run this. So 32, 42, now it's, 32 degrees Fahrenheit, 0 degrees Celsius. 212, That's 100 degrees Celsius. So that's what I'll be looking at. Notice we used a sub VI. So, we've done a 2D array maker. This is just a 1D array maker. So you probably figure auto indexing might be the way to go on something like this. So good luck, and hopefully you'll get all these VIs all done.